Hi guys, today we are going to study motion. What essentially is motion? Motion is movement from one point to another. It is the distance covered from one point to another because the object has moved from the two concerned points, say A and B. There are various things and terms associated when an object moves. There are a whole lot of facts to know about that object. How much, what was that object? How much distance has that object covered? Did he do so in a straight line or not? What was the speed with which the object traveled? What was the acceleration of the object? So on and so forth. And all of that is what we're going to study in this chapter. First and foremost, the thing that I am concerned the most, or we are concerned the most with this in this chapter, is a word called distance, and another word called displacement. So before defining it or saying the mathematical notation of both, let us see a practical example that shows us what both mean. Let's say there is a point A to a point B with, say, a distance of 30 kilometers. So my object or is one person who's traveled entirely from A to B. In this case, what is the distance? The distance is 30 kilometers. Let's say then the object has gone back from B to C, which is on the same trajectory. He reversed the direction and went back to C. So the distance from B to C is another 8 kilometers. Overall, I can say the person has covered 38 kilometers distance. Absolutely no ambiguity, irrespective of whether he just, in this case, he traveled in a straight line, irrespective of how he travels, whether in a circular mode, a square mode, whatever direction he travels, the distance will always be added as a positive. So, and it's a no-brainer. In earlier classes, we have learnt an expression for distance. Distance can mathematically always be given as speed into time. Then the question arises, what is the second word? It's possible we may be listening about it or hearing about it for the first time. What does the second word displacement mean? Displacement. So let us take the same example. Our object or our person has travelled from A to B and from B to C. So one person has travelled from A to B, B to C. Here once again 30 kilometers, once again 8 kilometers. The question is, what is the displacement? So from A to B, the distance covered obviously is 30 kilometers. From A to B, the displacement covered is also positive 30 kilometers. Why is that so? Because the point of reference, the starting point of reference of the object was A. The object travelled in one particular direction till point B in a straight line only. If that is the case, if the object has travelled in a straight line only and has not reversed or changed direction anywhere, then the distance and the displacement are said to be equal. So, now till this point the displacement is equal. However, the displacement changes the moment there is a change in direction. Unlike the distance, wherever the object goes, topsy-turvy, up, down, left, right, the distance is always going to be added. The moment there is a direction of change, no matter what direction it is, the displacement will be added as distance, however, in a negative form. Because the direction has been changed, that change in direction is denoted by a negative sign. So, the object has reversed its gear, reversed its direction and gone from B to C. I know B to C the distance is 8 kilometers. However, the object has changed in direction. Displacement, unlike distance, gets is dependent on a change in direction. So this displacement is absolutely computed. However, it is denoted by a negative sign because of the change in direction. So, what is the displacement then? 30 plus negative 8 is equal to 22 kilometers. If, let's say the object had gone from A to B, 30 kilometers, and had further gone ahead from B to D in a straight line itself, another 8 kilometers, then would the displacement have been 22? No, because the object has travelled in a straight line from A to B, 30, plus it has travelled another 8 kilometers from B to D, 8, so then the displacement would have been 38 kilometers. Displacement is wholly, solely, totally and only dependent upon travelling in a straight line. So, how can you bracket distance and how can you bracket displacement in this in that case then? Distance is what I call as a scalar quantity. Displacement is what I call as a vector quantity. Now, what is the difference between a scalar quantity and a vector quantity? A scalar quantity considers the magnitude only. What is the magnitude? The value only. So, there is no consideration of direction. Okay, 30, then another 8, simple addition, 38. If we had travelled in a circular way, then for another 5 kilometers, 38 plus 5, 43 would, that's what it is. A scalar is something that considers magnitude only. On the other hand, a vector like displacement is something that considers magnitude and direction. So a displacement changes, at least the sign of the displacement changes when there is a reversal in the direction. Okay, before I rub the board and go to the next slide, let me define two more quantities to you. We have a rough understanding now of distance and of displacement. What then, guys, is speed and what is velocity? I have already defined our smaller classes definition of speed. It is distance is equal to speed into time. So I can write speed as distance upon time. Velocity, guys, is a slight variation. It is nothing but displacement upon time. So obviously it follows that speed is a scalar while this velocity is a vector. Before I rub this, a thing to be noted: distance and displacement both have their units in meters or kilometers. Speed or velocity, both of them have their units in kilometer per hour or meter per second. So what did we just see here? We saw a term called distance, which is mathematically and physically defined as speed into time. We saw if an object goes from A to B 30 kilometers and comes reverses direction and comes from B to C 8 kilometers, it is just added up and 38 kilometers. The change in direction does not really do anything to devalue the addition or the computation of the distance. In displacement, for the same case, A to B straight line direction, absolutely no problem, it's plus 30. The moment there is a change in direction, the plus 8 is added as a negative 8 to denote a change in direction, because displacement, unlike distance, is dependent both upon magnitude and direction. One person, uh, again, we learned about scalars and vectors. Scalar is something that is dependent on magnitude only. A vector is dependent on both the magnitude and the direction. We also defined two quantities, speed. We just rearranged the definition of speed. It is distance per unit time. We also saw velocity, which is a modification of speed. It is nothing but the displacement per unit time. So, over to the next slide.